Holy smokes, am I by myself?
Whoa.
Oh, you scared me, bro. I thought, oh, and you're gone, bro. Oh, you killing me, man.
All gone. All by yourself.
Just two grapes on a vine.
Can you sing that? All by myself.
Oh, I was about to cry. Yeah.
Hey, guess who's not here this week?
Mr. Hughes.
Mr. Hughes he's on vacation, baby.
What did he say? He was in Yosemite?
I have no idea where he's at. He's like out, you know, I don't know what he's doing.
Yeah, we don't want his fans showing up.
He's spending time with his family. That's all I know. So
gotta respect that.
Sometimes we got to do that stuff, man.
Yeah, man.
We got to do that.
Absolutely.
So what's up, Mike? Hey, oh, by the way, welcome to the HVAC Grapevine. I'm Eric Kaiser. Over there, somewhere in another
over the rainbow,
virtually next to each other. We sat here. That's Mike Siegenfrocco. He's a smart guy on the show.
Yeah,
so anyway, now that we got that out of the way, like I said, absent tonight, Chris Hughes. He's spending some time with the family.
Yeah,
good for you, Chris. Have fun, whatever you might be doing tonight.
He was excited too, man. I'm happy for him.
Yeah. I was with him last week at ResNet in San Diego.
That's what I was going to ask you, man. You're flying all over the place too.
Oh, holy cow, man! Past couple weeks,
up to, bro?
Busy. So 2 weeks ago, I was out in Massachusetts for the Home Performance Conference Northeast or New England. I keep wanting to say Northeast, but it was New England Home Performance Conference. That's the name.
Nice.
But that's a regional like home performance conference put on by the BPA, Building Performance Association, and it was a pretty good show.
Performance stuff.
Oh yeah, lots of good stuff. Lots of people right now trying to figure out like heat pumps and things like that. There's a lot of people putting a lot of time and effort into figuring that stuff out. Like, how do we do this right? What do we need to do?
Okay, so there's a lot of legislation out there kind of pushing heat pumps. And
I mean, there's a lot of legislation. There's a lot of push from government entities, but there's also a lot of private interest in it. And there's a lot of people in like the building performance side and even the HVAC parts of the industries. And those people are really trying to figure out, how do we do this heat pump stuff that people are really wanting?
Right. Just pop that sucker in, man. It's easy.
Well, yeah, just pop that sucker in. I mean, it kind of works that way, but it kind of doesn't. Like, so, if we're going to go in heat pumps, it's a lot, especially on houses that need larger numbers of BTUs, right? Then you have to.
Oh, that's right. You got to do one of those load calcs for real.
Oh, wait. What was that called again? A load calc. Load calc. Who knows what that is?
Everybody's afraid of those, man.
Yeah, man. Running away from
trucking
away from them load calcs. Yeah, but I mean, like the load calc is just the first part of it though, right?
Yeah, man. Absolutely.
Yeah.
So a lot of these firms are got to be, really, like I'm assuming they don't have any wiggle room as much with, you venture away from gas furnaces up there.
Well, yeah, you don't have as much wiggle room. They're looking at, if you look at in the northern climates, but even in southern climates, you got to size things right. You got to size things to the needs of the house. You got to play in, I
just don't know why they're so
Jason,
afraid, man.
You're not right, man. You're not right. Jason Julian, you're not right. I'm reading his comment. He's over there on Facebook.
I forgot to look at the chat.
Oh yeah, I got to watch the chat there, man.
I got to look at the chat. You'll see me drifting. Oh boy. Oh, we got the Banana Man in.
Oh yeah, Banana Man's in there. Jason Julian's in there. American Temperature Control's in there. Tom Lex in there. Good evening, everybody.
Isn't that Doug? Is that Doug?
Yeah, that is that Doug?
I
I
think
think
so.
that is Doug. I think that is Doug. Yeah.
What's your name?
I don't
What's your
I
name?
can't keep up with all these company names. Like I know
I know,
people,
right?
but company names now, man, you start throwing that in and I get so confused.
Bro, I can't even remember people's names. I got to take photos of people, put them in my contacts.
That's why, yeah,
Mm-mm.
that's why everybody should have a photo in their contacts and share it like with their
Yeah.
contact. Yeah, it's a good
Or you
idea.
could do it like the New York way and just give everybody gets a nickname.
What's up, Doug? Hope you're feeling better, dude.
Yeah, bro. I'm glad he's doing pretty good.
Yeah, yeah, for sure.
Yeah, man.
Sure.
You know,
So,
people get nicknames like Pockets,
oh yeah, nice.
and just
Well,
people, you remember.
we might run out of nicknames.
Oh, yeah, well, that's true. That is true. We know a lot of people, so
You know, I have a hard enough time remembering my own name some days. Like a guy, I was talking to a guy out there at the Resnet conference last week, and I was like, I threatened to put my badge in my holder upside down so I could just flip it up and look at it.
yeah, that's right.
Remember who I was.
You got the Kaiser roll, man.
So like I was saying, heat pumps are an interesting thing,
Mm-hmm.
and this was something that I ran out. I ran this out a few weeks ago, and I might have to pull that up here. I might have to dig up a PowerPoint to pull this up. But if I can find that PowerPoint slide, I will try
And
to
that
pull
and
that
that
up in the middle of
was
this.
that one of the main concerns there was the heat pump situation that's really been going on?
Heat pumps are a big conversation, especially in home performance, any kind of home performance. So whether you're
Yeah.
talking about new houses, existing houses,
Okay.
and existing houses kind of get divided into two segments because you have what they call the weatherization community. So those are working more with the government programs on the low
Right.
income housing, and then you have the kind of middle class housing, which
Mhm.
in my experience is a lot of times a forgotten market. Like that's kind of where you work at,
Yeah.
and that's a lot of where a lot of HVAC contractors work at is in that middle class housing. But they don't get, in my opinion, most of the time from what I've seen, they don't get the same level of service that maybe a new house gets or that a weatherization program gets.
Yeah.
Because weatherization programs are going to go in there, they're going to do a really good analysis on that house. And stick with us, folks. This is all going to bleed into what we're talking about tonight.
Yeah.
Okay. So this is kind
Yeah.
of a precursor, and there's a reason why we're talking about MERV ratings, and this is going to go into air filtration tonight because this is a big part of this problem here.
Oh, the laundry's done.
Yeah.
Yeah, just wanted to let me know.
Wait a minute. You get laundry alerts on your telephone,
Yeah, it was just letting me know I'm done.
bro?
I gotta get
What the heck is your washing machine connected to?
It's
You
got
got
some juice,
you got a
baby.
Wi-Fi on your washing machine,
Oh yeah. Yep.
dude? What the heck?
I gotta yell at the wife. Laundry's done. But yeah. I don't know. Were you there for that conversation?
For
I
which
got a new
conversation?
washing machine.
No, man, I missed all that. Dude,
Oh,
really?
you missed
Seriously?
out. Yeah,
Oh, I
I got
missed
I
all
got
that.
the GE all-in-one, man.
Yeah. Wow.
Yeah.
All
Hooked to the
right.
Wi-Fi, no vent, one machine.
So you got like the heat pump washer, the
Got
heat
the heat
pump
pump.
washer and dryer and everything?
I'm
Oh
an
man, I
HVAC guy. I
missed
gotta
all
get the
this.
heat pump,
Heck yeah. Heck yeah.
Don't let me down, GE. Don't let me down. But you know what's cool is I'm glad you brought that up because I was doing a blower door and a duct leakage for it's kind of like a high-end builder that I work with. I'd say they probably do like 500,000 to like a million, like really nice beachside home.
Mm-hmm.
They're in that range. And one of the owners came and I was like, "Hey man, I see, you guys send me our energy calcs for the blower door, right?"
Yeah.
And I was like, I just so happen to look over them once in a while when I got no time. And you guys are doing a lot of straight cools. I was like, you guys are missing out on I'm not really too keen on what we got for incentives for builders, but if you guys ever want, just reach out to me. And they build tight homes. They're like 1 ACH to about 3 on accident. So it's like, dude, talk to me. One of my other builders has aero barrier. I was like, let's get this thing going, man. You guys
Yeah.
are
I mean,
missing out on opportunities. I was like, pitch it to your clients. You want to build like an Energy Star home, whatever you want to call it. I was like, I reach out. I got a bunch of jamokes online. They know what they're talking about. Let's make this happen. You know what I mean?
I love it. A bunch of jamokes
I was
online.
like,
I
all these
love it.
guys in a group. These guys are like scientists. We could send HVAC to the moon.
I love it. I love it.
Ah,
So, and we're talking about, a little bit about load calcs there and everything else. But so I did an interesting thing. I did a little experiment on my house, and I have got to go back. I got to go dig into Manual J and figure out what the tight, loose, semi-tight, semi-loose
right.
ratings are. I don't remember what the leakage rates are on those. I got to get that written down somewhere. But so I did a little experiment.
I wrote that down somewhere, dude.
So I did a little experiment on my own house. I just took my the load I had built for my house.
Okay.
The basic load, and I changed the leakage rate in there, and I set one to tight and one to loose.
Okay, cool. Yeah, I think I did that one time. It's
Okay,
awesome.
So all right, and I'm in Indianapolis. We got a little bit of humidity around here. We got a little bit of whatnot around here.
Yeah.
And so now I'm going to pull this. I'm actually going to, I'm going to share this to start off. I'm going to, whoops, that wasn't what I wanted to share. Okay, stop that. I gotta share something else here. Because like this is, and this was part of a presentation that actually Chris and Joe Medosh and I gave out at ResNet. But so these were the two loads. Whoops.
Okay, cool.
Yeah, that wasn't what I wanted to do. Anyways, so these were the two different loads, right? And loose came up with a sensible heat ratio of 0.65, where tight sensible heat ratio of 0.77. For those of you who don't understand that, that means loose 65% of the total load in cooling is sensible heat, whereas then 35% of that load is going to be in latent heat. And that's pretty hard for the air conditioner. For a standard air conditioner, is probably not going to be able to achieve that. You're going to have to do a lot of dehumidification, extra dehumidification with that, right? Whereas when I went over here to the tight rating, I bumped that sensible heat ratio up to 0.77, or 77% of that went into sensible heat versus the 22% or 23% in latent heat there.
That surprises me, man.
So
tight's at 0.77. So you and let me know if I'm wrong. Regular AC is 0.75, right?
Well, your sensible heat ratio varies depending on what you set your airflow to and what equipment you pass. So
that's true.
That's all over the place. That's set by your load calculation, though, because that's a demand of the house. Now, in order to match that properly with, you have to match the equipment to that ratio. And you would do that through the process of manual S, which is equipment selection, right? So
total different book.
This is all part of this here. All right. So the reason that fits into what we're talking about tonight is because we have to select the equipment in order to figure out what the airflow is going through our house.
Yeah,
so
man.
The total airflow going through this system, right? And these are a couple other things that I saw here, right? 19% reduction, right? Or just over 9,000 BTUs per hour by going from loose to tight. Now, our design temperatures here, 93 in the summer, 5 in the winter. All right. Cooling BTUs, total BTU reduction was 27%. Okay, because I went down 5,000 BTUs. So we went from 19.7 to 13.8, I think. I don't know.
That's wild.
Yeah, 13.6.
And dude, I'm so glad you brought this up, because what I told that builder was, it was like, with air barrier, we can come in and we could put whatever ACH you want to make this to. You want to make this an average house? You want to make it a tight house?
Well, here's the thing.
It's awesome.
You can show this really fast and easy with your load calculations.
Yeah.
Hey, Randy, thanks. Appreciate the shout out there. Good to see you at ResNet. And
I'm not doing them on these jobs, but it was good for me to go over it with them, because we had a load calc on the table.
But the thing is, like, if you want to know what that what that ACH is going to do, all you got to do is change that in your load calc.
Yep.
Because if
That's
you
it.
look at this, like this changed, that's a half a ton right there in cooling just by
Yeah.
tightening the house up. No insulation, nothing else, just by air sealing the house.
That's it.
All right. But this is the big thing down here to me, right? Sensible BTUs went down a little bit, but man, look at that latent reduction. Like
Now imagine
that
this
is
on that home I was
serious.
doing a blower door for. This house is 3,240 square foot, I think.
Mm-hmm.
So these numbers are going to be a little bit more dramatic, right?
Yeah. I mean, like my house is just under 2,000 above grade.
Okay.
Okay.
Cool.
So, and you can see what I got here. I mean, I went from 48,000 down to 38.8.
Okay.
So, I mean,
That's a big change
I can realistically do this with a 3-ton heat pump
with a
easily.
3-ton. Yep.
Yeah. Yeah. And I'm doing it, I'm down to a 13.6 on my, well, and this is actually pretty roughly my load where I'm at right now. I got a little bit higher cooling load than this, but not much.
And you got
And
guys just doing it per square footage, and it's just, it's going to be a 4-ton all day, maybe a 5-ton in
right.
my area.
So I've got to do some special stuff really to meet that cooling load and keep everything right. But we talk about that some other time.
Yeah.
Yeah, Jason, design temps are climbing. That's happening, but you need to size it to the existing design temp. Don't try to predict unless you're building in some way to control it to the current design temp versus future design temps.
Yeah. You don't want to put the input from what was it, Al Gore? And we'd be underwater by now, he said. So, the aquatics, not good.
Yeah.
Let's
not do aquatic heat pumps. Crazy.
Yeah.
So I just kind of wanted to show everybody that real quick because you mentioned load calculations and like load calculations are so important, but
yeah,
load calculations are only part of the puzzle. We've got to select the equipment with manual S and those guidelines afterwards because people are oversizing the daylights out of stuff. And if we're gonna go back in with the same 90,000 BTU or 80,000 BTU furnace and try to put a heat pump in based on that same sizing, we're gonna be so friggin' oversized in cooling, it's not even funny.
Yeah,
and that's
AC guys.
That gets dangerous.
AC guys are just afraid to please. They're afraid to get people upset.
Well, they are, but what kind of hurts them is that they end up getting people upset just by oversizing really that they oversizing is not cool.
Dude, the humidity control, it's bananas, man. It's just there's nothing there.
But even without humidity control in there,
excuse me,
we got to consider overall comfort too.
Yeah,
because longer run cycles equals better thermal comfort in a space. And when we start talking about thermal comfort, bigger equipment equals shorter run times.
Yep.
More off cycles. Okay. Especially when we're talking about single stage or 2-stage equipment.
Yeah.
So there's some things we need to pay attention to there. All right. So this is something else I want to show everybody here. Okay. So I did these calculations out. Gas furnace airflow. And this is really easy to reverse calculate. This is 160 to 370 CFM per 12,000 BTUs. All right. That is 12,000 BTUs of output. Okay. So we're talking about output here because I wanted to equalize this, these slides to the output of a heat pump so that we can compare really apples to apples airflow.
Okay.
All right. Does that sound reasonable?
So you got gas furnace airflow versus just like a regular heat pump airflow, you're saying?
Right. So heat pump airflow, 350 to 450 CFM per 12,000 BTUs per hour. Really, with a heat pump, we want to be on the higher side of this. You can get away with it, but you're not going to get quite as much heat out of it. The more air you put through the heat pump, the more BTUs you're generally going to get out of it.
Okay.
Now, there's a point of diminishing returns there, but typically on the heating side of a heat pump, we want to be in that 400 to 450 range, whereas maybe for the cooling, we may need to come down to 350 or so. But
that's where I like it.
If we look at this, this is a big deal, and this is a place where a lot of people are going, hey, what's going on here? Okay, so we could be up to 370. Now, if you're at 370 CFM per 12,000 BTU, you're down at like a 30 to 35 degree temp rise. That's pretty rare. That's in your really ultra high efficient gas furnaces. Most of your gas furnaces are going to be somewhere down probably in that 250 to 300 range. Most of your modern gas furnaces, maybe a little bit lower than that.
Yeah, okay. I don't work on gas furnaces, man. That's interesting.
Right.
That's a low airflow to me.
But the point is, that's per 12,000 BTUs of output.
Yeah.
Okay.
Yeah.
So if we flip that around and we talk about replacing like for like BTUs going from a gas furnace to a heat pump,
yeah,
what's going to happen to our duct system?
Oh, that's right. You guys have that issue with that.
So, well, it doesn't matter. Like if you have a system that's, because a lot of times in my climate up here, okay, in heating climates, and this is where heat pumps are getting really talked about a lot more, is in heating climates, because you guys down there, heat pumps are easy.
Yeah.
Right. In the southern states, heat pumps are easy. If I was down in southern states, man, I'd be putting heat pumps in all day. I don't need backup heat. I don't need anything.
Right. Where the 5 kW, just in case you feel a little,
maybe
you feel a little, insecure with yourself.
Not even that. No, no, probably not. Because the chances of it breaking down are going to be pretty slim. Number one, and number two, it's not that cold down there most of the time where it's going to be a big issue to fix it.
Yeah, you turn the oven on, throw the toaster on a little bit.
Especially if you got an electric oven, or throw some electric heaters in the house just to be able to do that. So if we flop BTU for BTU, output for output, from a gas furnace to a heat pump, and the duct system sized for heating, because needs the bigger airflow. Like
that's why everybody's talking about heat pumps, huh?
One reason why a lot of people are talking about heat pumps.
Holy schmozzoli, look at that, 163. That's why all the ductwork is that small?
Well, I mean, sometimes the ductwork's sized for heating, but normally in our climate, the cooling needs fewer BTUs, but the air, the gas furnace is going to be sized somewhere between the two. But if we've got to get the same amount of BTUs, so this is where HVAC companies really need to be paying attention.
Yeah.
Okay. It's one reason why I love the TrueFlow grid today, because it makes it so easy to walk into a house, take an airflow measurement, get static pressures, and I can start being predictive. It makes it really easy for people to be predictive.
Yeah. Dude, I use the TrueFlow grid for a leaky coil, like a water drip.
Yeah.
Guy couldn't figure it out. Nice guy. He's trying to clean the coil. I'm like, oh, maybe it is a TXV. I was like, you know what? I threw the TrueFlow grid on there. Static was good on supply. Static was good on return. And airflow was on the money. I was like, all right.
So when you wait a minute, whoa, when you say leaky coil, what do you mean? You mean refrigerant leak or water leak?
Water leak.
Water drip and water.
It's like a random dripper, like
what's
like
your super heat?
I was about to. It was last time. See, I checked it last time. Refrigerant charge is beautiful. It was like 8 degrees superheat on a TXV.
Let me ask you this then. What's your vapor line temperature?
Your vapor line temperature? Man, this guy is unbelievable. I didn't get none of that. Yeah, I mean,
how did you evaluate an air conditioner and not get vapor line temperature? How'd you measure superheat and not get vapor line temperature?
The vapor line temperature. I like that. Well, I mean, Measure Quick, I'm running Measure Quick. So if I get a flag for like a cold temp coil, like,
Ah,
I
but
would,
water drips.
yeah,
Water drips are caused by warm suction lines. Or
warm
okay,
suction
warm
line.
suction
Wow.
lines are going to be a symptom that causes of something else that causes water drips.
Yeah, it was like that when I was shooting January. I was getting a hot side of the coil. I was lost a capillary tube, I think,
The
on that
distributor
run.
tube, the
On the
distributor tube. Yeah.
Yeah, I always messed that up. That's right. You're right. So it was getting like as soon as the water was dripping all the way down to the last row, bam, it hit a row of warm
Yep.
and it was just dropping. Boom.
Yep.
I was
Yeah,
taking
if
it to
you
reg.
create a dry line on a coil, like if you have passes that aren't getting enough refrigerant, it's going to create a dry line on a
Yep.
coil, and that's going to cause water blow off.
Yep. It was just blowing right, just dropping right down.
Yep,
I mean, think about it too.
100%.
You have all that, you got 1200 CFM just pulling the water up. You figure it would just pull it up? Nope.
No,
On a regular air handler. So what I
it's
did
gonna
was I
because it's
got
gonna
that.
when it hits that warm metal,
Mhm.
the surface tension changes, and it won't hold onto the surface of that coil nearly as much, so it will tend to drip off of there more.
Yep. It like bounces right off, dude.
Yeah. Oh yeah, it falls right down. No problem.
So TrueFlow said everything was like right on the money as far as airflow. I was like, you know what? I'm just crawling in there doing the coil wash, and the coil rinse really, really did it. I think we're at like 2 months. It's been
Yeah.
at least
I
a
mean,
month.
you can start looking at
It helps diagnosing, man. I mean, dude, doing infrared, like get in there, like TrueFlow grid, it feels like 5 minutes for me now.
oh, it's so
You know?
fast. So
So,
fast. Yeah. I so wish I had that tool
dude,
when I was a technician, man. I'd
if I
been doing it.
started with this thing, come on, man.
Oh my gosh. Yeah.
Jeez.
Yeah.
I'd be
But
in there.
anyway.
I'd walk in like Conor McGregor, like with swagger. What you want? I'll fix this thing in 2 seconds.
So
But
anyways,
yeah,
so
sorry, I got you
the
off tangent there.
heat pump airflow, right? Okay. So we're there's two things we can do here. We can increase the size of the ducts, right? Which maybe already needs to happen anyways. And that's where kind of this whole MERV filtration thing is coming into play here we're talking
Mhm.
about. Because different MERV filters have different of the same dimensions have different pressure drops. Okay. So the other option here is if the ducts are maybe too small, maybe and number one, we got to do a load calculation to figure out what size the house really is and get this equipment right size. Because if you right size the equipment, then you get a better picture of what you actually need to do.
Yep.
Maybe the ducts are just fine. Maybe the unit's too big for the house.
Yeah.
So if you size it off of a square footage per ton rule of thumb, or you're just going back in with the same thing that was in there before, you may just be putting yourself in a world of hurt and your customer in a world of hurt. And you may be, ticking your customer off, which you really don't want to do.
Yep. Like for like. I didn't do nothing wrong, man.
Right. Like for like, baby. Yeah, sure. Well, if the other one was a piece of junk, the new one's probably going to be a piece of junk too, because you just put the same thing back in there the same size. If it
A
didn't
new
work well
shiny
before.
turd.
Yeah, shiny new turd, baby. I like that. Yeah, Jason Johnson. I like let me I'm gonna stop this. I like the idea of using SCRs. SCRs for modulating heat is a great thing. It is it's a little bit beyond what's typically found in residential, but I think it would be a really fun thing to play with in residential for comfort, personally.
What's he talking about?
Silicon controlled rectifier, or SCR. Basically, it modulates electric heat. So you don't
Damn.
have that on off of electric heat.
Oh wow.
It's a modulating electric heat. Whoa. Adam, I don't know what's up, buddy.
Uh-oh.
I can hear me and I can hear Mike. So hopefully it's a I don't know.
Kaiser check 1 2.
Hello, check. I can hear me.
Now you got to say mic check because I say Kaiser check.
Mic check.
1 2 1
Okay.
3.
Adam, I think it's you on your end, buddy.
Get new
Jason says he
Bluetooth
can hear us.
headphones.
New Bluetooth headphones. Check that connection. Check your volume. Check your output source on your computer.
That's really interesting. You can modulate the heat kit.
Yeah,
I'm liking it.
it's more commonly used in commercial settings and
Okay,
in like VAV boxes is where I used to see a lot of them. So
that's cool. So
um,
what? You're not holding like that. You're not getting that heat kit cherry red. Just kind of like on off.
well, it basically just modulates it to a set temperature, and then you can modulate that up and down.
Okay,
Is the simplistic way to put it. It's not an on off like a light switch or like a contactor or a
right.
sequencer. It's a way to modulate that heat.
Do you familiar what they did with Train Residential? Did TAM 7 had like a circuit board on their heat kit?
Yeah,
Because I really
I don't know those things.
I missed the boat on that.
Missed the boat. There you
But
go.
you know what's funny is they got rid of him. Went back to the old contactor.
Yeah. So, um, so you know, we got to really focus on airflow here, and this is gonna,
Big time.
um,
Especially with the MERV.
yeah, with the MERV. So let's get in. Let's talk about first. What the heck is MERV?
Yeah, what is MERV? Huh,
What is
Marv?
MERV? I know a guy named MERV.
What do you say, Vern?
Yeah, exactly. His name was
Remember
MERV.
that?
I used to
Remember that
work
guy?
for a guy named MERV. He's dead now, though.
Hey,
He's
Vern.
cool. He was a cool dude. I like old MERV. But anyways, yeah. So MERV is
Minimum efficiency. What now?
a minimum efficiency rating value, right? But that's a thing that's based on a test that is done by or specified, not done, but a set of specifications put forth by ASHRAE.
Okay.
Okay, minimum efficiency reporting value, and
So
that
ASHRAE made a standard.
ASHRAE. Well, ASHRAE makes a lot of standards. So if you're not
Hmm,
familiar
hmm.
with ASHRAE, that's the American
We went
Society
over
of
this
Heating,
last time.
Refrigerating, Air Conditioning Engineers. Yeah, see the other podcast or the other live stream we did all about different
I'm
organizations.
learning a lot here.
Yeah,
You set the bar.
yeah.
So the filter company is going to try to make close to that
So
standard, right?
well, they have a set of standards, and there's some different testing criteria in there, and we could do like hours just on that testing criteria, but I don't want to get into that
Let's
too
do
much.
it. Let's go overtime, man.
So
Let's bring
let's
Adam on. Let's go.
I'm going to show another slide here. All right. So,
Tell the wife we're going to be like Joe
okay.
Rogan tonight. We're going 3 hours.
Okay. So I'll try to zoom in a little bit on this so y'all can see this a little bit better because it looks a little fuzzy there on my screen.
There
Is
we go.
that better? Is that
Oh,
clearer?
that's good.
Okay.
Look at
So
you. We're getting fancy, man.
what this does is MERV is a rating system that goes from measures the amount of dirt captured between 0.3, that's 0.3, and 10 microns in diameter. So that's the range that MERV looks at. Okay. And typically
Scoot that down just a little tiny bit.
do what now?
I like to see the headings.
The headings?
Yeah,
Yeah.
just like
What, like that?
yeah,
Okay.
my man.
Okay, well, we're going to scroll down. So, here's your MERV rating there on the left, right? And this is the average particle size efficiency in microns on the right.
So everything's for microns with MERV, pretty
Yeah,
much.
micron. Now, keep in mind, in the air conditioning world, we talk about microns under vacuum, and that is microns of mercury because micron is actually a unit of distance.
Distance, really?
Yes.
When I think of microns, I think of Jim Bergman.
Okay.
What would Jim
Micron is a
Bergman
unit
do?
of distance, which means microns of mercury, right, is a unit of distance on a mercury scale.
Okay.
All right. Kind of like inches of water column or something like that, but it's a pressure measurement. Right. So
Okay.
so this is microns in diameter of particulates is what MERV is all about. So typically most of your only house. Yes.
Oh, we got Housh in here. Nice.
Yeah. Micron.
I need
has
a-
2 first names. Thanks, Housh.
Yo, what's up, Micron? I need a separate computer for the comments.
No, there you go. Okay. So typically your base pleated filter. All right. Now that's just the filter with it kind of looks like corrugations in it or something like that in it, right? Is about 8 micron or MERV 8. So
MERV 8. Okay.
it's going to capture greater than or equal to 20% of 1 to 3 micron particle sizes and 3 to 10% or greater or equal than 70% of 3 to 10 micron particle sizes.
So that cheapy Home Depot green filter, you're saying it's going to be like probably like 8 below,
8 below?
8 to
8
like
or
a
below?
5.
I don't know. I'm not familiar with that filter. I'm saying this is just like your basic pleated filter.
Yeah.
When you go
Okay.
down into like the um your MERV 2, MERV 3, MERV 4, that's down in that what I call a hog hair filter or a
Rock
huge
catcher.
rock catcher filter, right?
Yeah.
You're not catching anything less than 20% of 3 to 10 micron particles. You might
20%.
catch the cat or a ping pong ball
Yeah.
that gets down the duct, but you ain't gonna catch much else.
You get that deflated happy birthday balloon that's been staying in your house for 2 weeks.
Exactly. So we scroll on down here and we don't even get to measuring that 0.3 to 1 micron size until we get to MERV 11.
MERV 11 is it's like your, I don't know, my gateway MERV filter.
That's realistically a gateway filter to getting halfway decent filtration in your house and starting to clean the air up a little bit that goes through it.
Yeah.
MERV 8 filters will keep the equipment clean, all right, from the larger particulates, provided they'll do a pretty good job of keeping the equipment clean, provided, and I'm going to say this very, very clearly here, that there's not filter bypass around it. There's not what's called filter bypass, which is where there's a filter sitting in a rack and the thing rattles around like this and allows air to go around that filter. Well, with that air comes dirt.
And bro, let me tell you, everything's got filter bypass.
Everything has some amount of filter bypass, but when you get a really loose filter rack, man, the filter bypass gets bad.
Dude, it's the worst.
Or if you have too small of a filter, and we're going to talk about this.
Yeah.
Too small of a filter, physically
filters.
Not too small for the rack that's in there, but you have too small of a filter rack.
Right.
All right.
And what that means is static.
You get a lot of pressure. Okay. And with static, we're talking about static here. We're talking about pressure pushing on that filter, and it pulls the filter out of the rack, and then all kinds of air gets around it. Your equipment's going to get filthy. And that costs you money, not only in operational cost, in heat transfer cost, and in repair cost eventually.
Yeah.
Okay.
Yep. So higher that static, the more bypass you're going to get, man.
Yeah.
That's why filter grills, I tell people, just tape them suckers in with that blue tape.
Yeah. I mean, as long as the filter's big enough to handle the airflow going through.
Yeah.
So, I mean, man. MERV 13, right? That's where we get 90% of those large particulates, the 3 to 10 micron. We get 85% of 1 to 3 micron, and we get 50% of that 0.3 to 1 micron.
That's why I just upgraded to MERV 13.
No, I mean, that's not bad filtration right there. And in some states now, that is actually the minimum filtration they're allowed to put in equipment.
Damn, what state is that?
I want to say that's like New York, maybe.
Wow.
Your favorite state?
Dude, that is the capital of, I'm going to push you to do this, or you're going to move.
So I'm just
13.
That's the standard. Now, I don't quote me on that. Somebody that lives there might be able to tell me, but
we'll look into it.
Thinking that I remember that I heard that.
When we get a bigger budget, we'll get somebody reporting on the street here soon.
Yeah, right. So, and then we get up to like MERV 16. Okay, that's your highest MERV rating. There is no MERV rating above 16. That's as high as it goes. Okay, so then you're getting 95% of all the test particles going through it. Right. But when we get up in these higher MERV ratings, say if we're running 20 square foot of filter surface area, just as an example, I'm going to use 20 square foot.
Yeah.
To capture these smaller particles, what happens to the size of the holes in those filters?
They get reduced, man. It's not like Swiss cheese no more.
Yeah, it's like microscopic whole Swiss cheese. So when that happens, the resistance, it's kind of like trying to. I like thinking of a MERV 2 as one of those giant straws you used to get with the big milkshakes at Burger King, like so you could suck that the Oreo chunks up there, right? Anybody remember those? Okay, that was I mean that straw was like 3/8 of an inch in diameter. It was huge.
Yeah.
But a MERV 16 is like trying to drink that milkshake through a coffee stir.
Dude, it's crazy, man. When I jumped from a MERV 11, 24 by 24, MERV 11, right? On a
Mhm.
3.5 ton.
Mhm.
That sucker lasted for a year and 2 months. A year and 2 months, the total external static pressure got to about zero point 0.6. I gotta look at the numbers,
Point
right?
0.6?
I mean, what the hell would I get? Yeah,
Oh,
it was
and are you talking total external static or are you talking filter drop? Let's
total,
talk about
total,
okay.
yeah, total
Ex
external.
external static doesn't mean realistically anything unless we know what we started with. But let's
Right.
talk about just that filter drop.
Yeah,
You
just
got
that
that?
filter drop, man, it was really low. Like it was really low. All right. So, and at the year mark, I checked it, right? So then I went to a MERV 13 and right off the bat, clean, I was like, "Holy smokes, it's high."
Yeah,
It's a
yeah.
it's a big jump.
It makes
Just
a big
just
difference.
just talking dude talk, no numbers, but that's you if you want to go 13, you're most likely going to have to do a huge big ass drop and you're going to have to maybe do two. When you're doing MERV 11 and down, you're doing like one filter, you got to start rethinking the project.
I mean, either that or you gotta go with a lot bigger filter.
Yeah,
Like, you
uh,
just gotta go
two
with a
or yeah,
huge,
you go
huge
huge.
filter.
Yeah.
You know,
Yep.
I that there's really one I think only April Air is like the only one that I know of that goes above like a 20 by 25 filter, right?
Oh yeah,
I
April
think
Air is
that's
pretty
accurate.
flexible, man.
Yeah.
I
Those
wish I
guys
was.
got some nice filter cabinets out
Yeah.
there. Yeah, there you go. Yeah, that April Air 1510 with
Yeah.
MERV 16 and really low static. House out there, House is doing super stuff. He's doing MERV 14. Well, and this is a thing here too. So filter MERV rating may degrade because they use electrostatic charge on the particulates, and after that electrostatic charge comes off, it might not gather the particulates the same.
Okay.
But
It might not gather it.
House here is super filter. He's running MERV 16. I'm guessing
Woo!
HEPA bypass, probably not all your air through the HEPA.
Yeah,
I'm
Mike,
guessing
is
your
that your
house.
bypass?
Yeah. But anyways, down here in that HEPA, right? HEPA range, 99.97% of particles in the zero point 0.3 micron range. Okay. And then larger or smaller than 0.3 are captured with greater efficiency than 99.97.
Yeah.
So HEPA is a really great filtration, but you're not going to run 100% of your air through that. Most of the time you have a duct here, right? And the bypass will have its own fan in it. So it'll pull air out uh, at one point and it will re-inject it back into
Yeah.
that duct downstream.
And let me just make a little public service announcement here. I know we're all dudes and we like to not,
Not all of us.
like, yeah, I know.
Not
We
all of
got
us.
we got we got like 3 women fans,
Okay.
but we're not like women and we do stupid shit sometimes. When you're taking these filters out, don't forget, there's a year amount of filter and dust. Wear a damn mask, man. Don't be counterproductive on that. Like that, like we're talking like small microns of dust is pulling off of there. And you walk through the house, man, wear a
There,
mask when you're pulling that thing out.
you know what? There's a reason that that filter has a plastic bag on it. One, it's keeping the new filter clean when you're walking in and when it's bouncing around in your
Yeah.
truck. Number two, you take the new filter out of that plastic bag, you put the old filter right into that plastic bag, maybe
Yeah,
grab a
man.
little tape and throw it in there.
Yeah. That MERV
Um
16, you could probably just pan for gold with that damn thing, man, when you get done. Might have some plutonium in there and
yeah. So here's what House is doing. He's got a HEPA bypass and only comes based on his IAQ.
oh, that's awesome.
And then he runs a portable HEPA all the time in the living room.
That's awesome.
So, but that's a little bit about like what MERV is. Okay. Now, this comes into play, number one, when you want better air quality. If you're a homeowner or whatever that's watching this later on, and you want better air quality in your house, don't just run out to the hardware store and buy a new air filter.
Yeah.
Because chances are your original air filter is probably too small in the first place, unless you have a really big media filter in there. And even some of those are undersized. Like
Yeah.
I can think of maybe 1 out of 100, maybe probably more than like one or two out of 200, 300 that I've seen sized correctly in air filters. Most air filters are way undersized.
Yeah.
So don't just go running out, throwing in a high allergen catching filter. Like you're going to have it, you're going to cause more issues with your system than you're going to solve. Okay. So if you want better filtration on your system, make sure that you get a proper sized air filter put in there by a professional, not just somebody who's going to slap it in. Like
Yeah.
they need to be sealed in there properly so that they're not sucking in more dirt afterwards.
Call an HVAC guy. Yeah.
Call a good one.
And
I hate to tell you, there's a lot of
that's a good point, bro.
I'm sorry, folks, but there's some bad HVAC contractors out there. There's a lot of good ones, but there are some bad ones.
Don't spill the beans.
Sorry, I've been in this industry long enough. I'm going to call it as I see it. There's some bad ones out there.
It's rough out there.
And guys and girls in the HVAC out there, we all got to do better. I've done dumb stuff. Hey, I'm right here to tell you, I've done dumb stuff that I probably shouldn't have done, but I like to think that I learn, but we all got to learn from each other. Learn from each other. It's way easier to learn from somebody else's screw ups than it is to learn from your own screw ups. It's a lot cheaper.
And who cares? You move on. You do better as a company, as a technician.
Yeah, as a person.
You didn't do MERV 11 last year. You didn't do anything. You do rock catchers. So what?
Yeah.
Move on.
Yeah.
Read the literature. You could do better.
And I'm going to tell you right now, one of the easiest conversations I've ever had with my customers over the years when I was still in the field was that, hey, guess what? I changed the way I'm doing stuff because I went to a class and I learned something. I learned something new.
I like that. I'm stealing that from you.
I'm out here keeping up my education.
I like that.
I'm out here doing what I'm supposed to be doing. And you know what? You see doctors have to go to classes. They have to learn new stuff. Engineers have to go to class. They have to learn new stuff. Why the heck shouldn't we be going to classes and learning new stuff?
There's new procedures that come along, advances in medicine.
You read about, if you put on a Google alert about HVAC or anything like that, what you're going to do is you're going to see that there's new inventions, new advancements, new stuff all the time. Hey,
that's right.
Why not look, I ain't selling the same cars we used to. There's all kinds of new stuff. So go learn something new and admit to your customer that you're still learning. There is no way you know everything.
Yeah. And some people like that. Let them know you went to a convention or a conference or training class. And hey, I learned something new, and let's throw 2 filters in there and increase the airflow.
Yeah, I learned that there's better ways to do this, and I can I can provide you a better service because I went and learned something new.
And you know what I want to ask you, dude? Speaking about filtration, I remember back in the day we had this car salesman come in to the shop, and he was saying this 1-inch electrostatic fiberglass filter, reaching amazing MERV ratings and whatnot. What's your take? Have you heard of the technology? It's been around for a long time. It's a little probe with a 24-volt pack. Have you heard of these?
I think I know what you're talking about.
Little electrostatic.
I've seen some do some good. I've seen some not.
I stopped selling them a long time ago.
I think that they work. My house. There you go. That's what I was trying to come up with. I think it's a dynamic air cleaner. I've seen
that might be it.
what I've seen on
That might be
electronics, and what I've seen on any electronic air filters, is that velocity really, really matters on them.
Mm, okay, so you get a lot of airflow going across and
Not volume, velocity.
velocity. Okay.
Okay.
Yeah, Jim Bergman was talking about this. If you get a lot of velocity, it'll pull anything out, even
Yeah.
like on the higher end filters.
Well, it depends on what kind of filtration technique they're using because
Hmm.
there's just straight up capture. There's all kinds of
Right.
stuff, but um, especially because the electronic air filters rely so much on particle charging and using that
Right.
electrical charge to capture it onto grids or whatever that may be.
Wow. So that's yeah, if you got a high velocity, you could really just pull that magnetic charge off, dude.
Right, because it's not a
Holy
super strong
smokes.
charge, but it's a charge nonetheless. Because 'cause you're charging the
Right.
particle and you got an opposite charge plate or fabric or whatever there, and it's
Right.
sticking to that. So if you get a super high velocity coming through there, it's just gonna pull that right back off,
Yeah. You just pull
okay?
like all I picture is like a dog hair, a long dog hair go like just going right through
Oh,
there.
yeah, yeah, 100%. They will let big stuff go right through a lot of times.
Yeah. It's just
So
fiberglass. Yeah.
so,
It's those like
low
50-cent filters it reminds me of. It's like that
yeah,
real
yeah,
yeah. Okay, yeah.
low resistance, but you need low velocity through those.
Low
So
velocity.
you really gotta get in my experience, I wouldn't put one of those in unless I was down in the 100 to 150 foot per minute range,
Woo wee.
right? Which is
Okay.
if you understand velocities in ductwork is super freaking slow,
Yeah, okay. Yeah, that
okay?
was
Because
that's what I was looking for.
a lot of filtration that is sized, but is sized more in that 300 foot per minute range
Yeah,
or higher sometimes. Well, depends on if it's sized right. If it's properly sized, it's probably going to be between 150, 300 feet per minute, somewhere in
yeah.
that range.
I got a good
I'm gonna be
customer at
I'm
one,
gonna be
so
on the way low side of that for electronic air filters.
and then so a lot of our higher end stuff does have a charge that wears off what? I'm thinking a couple months. What do you think?
Really depends on the filter. Because
Yeah.
sometimes the velocity of the air going past it, or depending on how the air is going past it, it might create a recharge in there.
Oh, really?
I
Huh.
mean, well, think about what happens when you do something like rubbing a
I'm gonna
balloon properly. You rub a
yeah.
balloon and it's really well, okay, you're in Florida, you don't know
Yeah.
anything about that.
Well, I usually go to my filter once a week and I give it a good massage, so
Okay.
get a little
But I'm
static. A good
my
good filter
my
maybe.
thing
Good
is there's
filter.
different ways we're talking about electrical charge here.
Right.
But the
Right.
electrostatic charge on filters, yeah, does wear off. And typically, if you see like a filter says replace after a month, replace after 3 months, that's when that electrostatic charge is
Oh,
expected to wear off.
gotcha. Okay, cool. That's interesting stuff, man. That is interesting stuff. I
So when
wonder if anybody's doing a paper type media filter with an electric static start. I've never seen one with an electric charge, like a supplemented low voltage. That would
mm,
just cause a house fire. That's
so
probably why.
you have some like the April Air did some and
Oh, they did. Okay,
I think
cool.
there was an April Air for a while that had like an electrostatic grid in front of the paper or fiberglass filter.
Oh yeah, like the Clean Effects from Train. They run like a
Kind of.
grid.
No, because you took this out and threw it away. It was a throwaway piece where the
Right.
the Clean Effects is a washable thing. But
Yeah.
something like that. Yeah. Yeah.
Okay, cool.
But
Yeah,
I
that's
don't
interesting
remember.
stuff.
I don't even know if they make that anymore. It was like a 5,000 series or
Okay.
9,000 series.
Dude, talking about all this MERV, man, I think I'm gonna upgrade. I think I might go higher than 13 with the new AC. I'm gonna pop in here eventually.
Yeah,
Goodness
April Air
gracious,
5,000. There you go. The Mike
5,000.
Mike and Doug knew what they're talking about there. Yeah,
Of course,
April
they
Air
know.
5,000. That was and it was a big. I mean, the thing's like about a foot thick. It's like 10
Oh
inches or a
yeah,
foot thick. It's
really?
ridiculous.
Because a lot of these MERV 11s, I pull them out when they're done, and they're like about 12 feet long on like a 24 by 24.
Oh yeah, yeah,
So,
absolutely.
dude, the April Air, remember the one with the combs?
Mhm.
Dude, those are gotta be crazy.
Yeah.
Those are gotta be like 20 feet long, dude.
Yeah, so they still make the 5,000, it looks like. Um, but so it charges electrostatically and then feeds into um, a replaceable filter, which,
Okay.
it's a different way of doing it. And there's a
Yeah.
lot of the challenge I find on a lot of these, is that there's a lot of claims made, and maybe the testing is different
Mm.
because there's a lot of, and you got to figure out, like, if they're testing that and they're saying that it is, and I'm looking at the April Air 5,000. It looks like it's performance tested to ASHRAE 62.2.
Wow.
62.2 is an outdoor
That's
ventilation.
fresh air.
That's a fresh air ventilation standard.
Yeah. Throw that in there.
I'm
I
really
like the way that
scratching my
sounds.
I'm scratching my head on that one, guys.
This
We're
is
gonna have to
brought
get
to you
somebody
by
on April.
62 too.
We're gonna have to get somebody on April Air here and talk about that because I want to understand how they're testing that against that. But
Should
anyways,
should
so
we get
yeah,
them
like
on and fit them in maybe like right around April?
they're I said something one time. I
We're
said I wanted to
booked in
start a
May.
company called March Air, so they'd be 1 month ahead of April Air.
Dad jokes all day.
All day,
All day.
baby, all day, and all night too.
March
Don't
Air.
don't forget to tip your wait staff. I'll be here all night,
March Air.
at least for another few minutes.
That is funny. Funny stuff.
Yeah,
Dude,
but that
so
like they say it's like 99% of airborne viruses and ultrafine particles down to 3.3 microns in size. So, with that electrostatic charge in there, I mean, maybe it does do some good. I don't know.
that's what I was thinking, man. Because like that
But
electrostatic charge goes. I mean, you're losing quite a bit.
but if they're performance testing against and I don't remember, I don't know what part of 62.2 they would be performance testing to. Like that makes me like
Yeah,
scratch
it's like
my
we
head a little
also
bit.
this filter performs to standard 310. Yeah, it's like throw that in there too.
Don't even We're not going to talk about standard 310 tonight. My head had enough of that last week, and
So
I don't want to talk about that
what
until tomorrow at work. Okay.
what else did you two knuckleheads do on this whole travel around the world
Oh my goodness. So
and preach the word of HVAC?
like I said, the week before, 2 weeks ago, I was at that BPA conference, the
BPA?
New England Home Performance Conference, and then
Okay.
last week, Bill and I took a week in California. Sunday we flew in to
You and
California.
Papa Spoon went to California.
Me and Papa Spohn were in California for a
Unbelievable.
week. Yeah. So
This, you're actually getting paid for that?
yeah, I mean, they paid me to go. So
I would do it pro bono.
you would? You hear that, Bill? I might be
Dude,
out of a job.
that's
Man, I
that's
might be
it.
out of a job here soon.
What'd you guys do in California?
So
Oh,
Monday,
wine tasting?
no. I might have had a glass of wine, but definitely not a wine tasting.
All right.
It wasn't bad wine though. I mean, I probably drank a couple of glasses of it there at the event one night.
Nice.
But it was a lot of long days and meeting a lot of new people. So
Mhm.
Monday was up in Berkeley,
Oh, wow.
which is in up around the Bay Area.
Nice.
Was what's it called? Heat Pump Summit. And
Oh, that's right.
this
I
was a new
forgot.
event. Yeah, with Brent Davidson. We
Yeah,
had him
we
on
had
here
him
one day.
on. How'd
Yeah.
it go, man? Good?
It was a pretty good event. It was interesting. It was a smaller event. There was a good number of contractors there. A lot of plumbers, because plumbers are really getting
Wow.
interested in heat pump water heaters.
Oh, okay. Would
And
you look
again,
at that?
California,
I should have went. I got a heat pump washer.
California, much like the South, is really good climate for heat pumps a lot of times.
Yeah.
Not
Yeah, it's real
not
dry.
yeah, dry and cold. Or dry and warmish, not cold.
Yeah,
Dry
yeah,
and not cold is what I meant to say.
yeah, it's pretty dry. It's beautiful climate, man. If you
Yeah.
could afford it.
So, yeah, if you can afford it, man, there are so many
Mhm.
people out there. I'm like, holy cow! I just ridiculous amounts of people. So
So,
then,
how long does Summit last for?
Summit was Monday,
Okay.
and that was pretty neat.
Awesome.
Met a lot of new people, a lot of good people there. Found out some new stuff,
I'm
and
glad everything
then
went good. That's cool.
Tuesday we flew down to San Diego, and
Oh, what a shame.
San Diego was the ResNet conference. So Wednesday, Thursday, Friday was ResNet, which is Residential Energy Services Network, which is those are the people that do the HERS rating on the new houses. And met a lot of really good people there. A lot of really interested people. They were looking really hard. A lot of those people are looking really hard at the ASHRAE ResNet or ASHRAE ACA ResNet Standard 310 because that gets extra HERS points
Big time, yeah.
for their houses for the HERS ratings. So they're looking really hard at that. The interesting thing there is that most of those people are not HVAC people. They're raters, which means
Is
they're
it
used.
really that much of a disconnect?
There
The
is a
rate
huge disconnect between raters and
really?
HVAC people. Oh, massive, massive.
Well, that's why when we go to Orlando, they call us unicorns, huh? I don't know.
So
Wow.
the disconnect between the raters and and that is massive. Are you a HERS rater?
No,
No.
no. I was
Okay.
thinking about getting into it, man.
I see there being a really big connection between HERS raters and HVAC, and we should be working together 100%.
Yeah.
But one of the big disconnects is now with standard 310 is they're taking non-invasive refrigerant system method tests, which is basically temperature and
Oh, that's right.
air temperatures, line temperatures, and they're also doing some wattage measurements. Okay.
Wow. So they're getting like mini maintenance guys. Yeah.
Kind of, but not really. I mean, they're not going that deep into it. All they're doing is making checks
Yeah.
to make sure whether or not the system meets the standards. And it's all on new houses. So there's nobody
Right.
living there at the time. So
That's cool.
they historically have not done any sort of anything with the HVAC system outside of duct testing. They do duct testing.
Right.
You
Right.
know,
Right.
for
Right.
leakage. And then they go into now they're going in to do watt draws. So this means, occasionally they got to open the equipment up, they got to
Yeah.
put on a meter. So they're having
Where
to learn
where
how to
could you
do that.
get like a fancy meter like that? Where would I buy one?
I don't
Hmm.
possibly
I heard
know.
of this is like a website.
Yeah.
Tommy Tech. Was it True Tech Tools or something like
True
that? I
Tech
don't know.
True Tech Tools.
Yeah, I
Yeah.
heard of
I
that
think I've
place.
heard of them before.
Yeah.
Yeah.
So now you got
TrueTechTools.com.
HERS raters, like they're getting into like doing. They probably don't own voltmeters and amp meters and stuff like that.
They're having to tool up completely for this
Wow.
because it's a different world for them. So
Yeah,
I'm
that's
actually going to be
interesting, man.
doing some classes for them on how to take watt readings in accordance with their standard safely, things like that. Because a lot of them, I heard a lot of
Wow,
people doing what I thought was some pretty dangerous things at times there. So
that's a
want to make
big
sure that
jump
they're doing those
for
right.
a raider to just start touching electrical. That's
Yeah,
you're gonna have to bring up safety, disconnects, and all that stuff,
yeah,
man.
yeah. It's a bit of a jump. So.
That's a big jump. Yeah,
But like I said, that's some different things. So what have you been up to?
I'm thinking about doing this now. I forget. There's somebody north of me who works with Quick Model, works with Energy Gauge. Energy Gauge is I for,
Florida Solar
yeah, that's
Energy
right. Florida. Yep.
Commission, Florida Solar Energy Commission.
I
Yeah,
think they do
FSEC.
like a energy rating stuff. I don't
Well,
know if
that's
they
part of
were
their energy rating software, but I don't know if they're so. ResNet's kind of an interesting thing. So you have the raters, and then they work with a provider
okay,
that double checks the raters, and then ResNet double checks the providers and the raters, and they have a whole
like a
system thing.
quality check. So if
Yeah.
I do a job, they do a quality check. Oh, that's
Yeah,
cool.
there's periodic QCs on different people and whatnot. It's an interesting system.
Wow, that's cool.
Yeah,
Yeah,
I learned a lot more about it. Or I should say, I learned a little bit about it. For me, I learned a lot about it because I really knew very little.
I'm already doing blower door and duct testing. I got a
Yeah,
meter.
yeah. I mean,
I got a true flow grid.
there you go. You're
Yeah. What do
you're
I
pretty
need?
well in there.
I
You
need
got
a
a lot of the
sticker.
tools already.
I need a certification. That's it.
Yep, you got to have certification.
There's probably going to be a lot of classes to get
Maybe.
certified.
but you might learn something.
Yeah. Yeah. Always. Never stop.